Alright, so in this video, we're going to cover the rest of the questions, and I quickly wanted to revisit this part. Okay, sorry, my stylus is not working. Alright, sorry about that. So, let me try to reconnect my stylus. So, I would like to revisit question 8, because we realized after using the law of cosine that this is your right angle, right? And how can we test that? Well, if you take this side, 6 plus 2, this is 8, right? 4 plus 2, this is 6. And 6 plus 4, this is 10. So if you use the Pythagorean theorem, 8 squared plus 6 squared is equal to 10 squared, you see that you get 100 is equal to 100. So actually, you can, if you use the Pythagorean theorem to figure out whether this is a right triangle or not, you see that this will be your right triangle, and 10 is your longest side. So you can do alpha and beta like this, and you can easily get the values of alpha and beta. Why? Because take the sine of alpha. Sine alpha is going to be opposite, which is 6, over the hypotenuse, which is 10. So sine alpha is immediately 0.6, and alpha is immediately sine inverse of 0.6, right? And beta, take the sine of beta, you get sine of beta is 8 over 10. So beta is sine inverse of 0.8. So you immediately get your angles alpha and beta. So you immediately get alpha and beta. And once you have these angles, it's very, very easy to calculate the area of the sector, right? So we can divide it again. Area of sector 1, 2, and 3. And this is a 90-degree angle. So what is area of sector 1? Well, it's half. The angle is 90, so pi by 2. And the radius is 2 squared, right? So this part, radius is 2. The angle was 90 degrees, so pi by 2. And when you plug this in, you are going to get pi. What is this area of sector 1? What is area of sector 2? Area of sector 2 is going to be half. What is the angle? Angle is, I believe this was alpha, right? So alpha is sine inverse of 0.6. Sine inverse 0.6 times, I don't remember what I named alpha and what I named beta. I think this was alpha. Yeah, that was alpha. All right. So 0.6 times the radius is 6 squared. And if you put this into your calculator, you get 11.58301,996, something like that, right? And let me see. 11.58301,996. All right. And area of sector 3 is going to be half times sine inverse of 0.8 times 4 squared. If you want to find this area. And when you plug it into your calculator, you get 7.418361,744. And now what is the area of the triangle? Area of the triangle is half base times height, right? Half. The base we already know, discussed, is 10. This is the base. And the height is going to be given by, as discussed in the previous video, 8 sine of alpha. 8 sine of alpha. All right, and if you plug in the values, so 0.5 times 10 times 8 times sine of sine inverse. What is alpha? Alpha was sine inverse of 0.6. So sine and sine inverse will cancel each other out because they are inverse functions. So you only get so because they are inverse function, remember, f of f inverse of x, it just gave you x, right? So you just use that property. All right, 0.6. So you get 0.5 times 10 times 8 times 0.6. That gives you 24. All right. So now you do the following. 24 minus pi minus this, and your final answer is the same, 1.86 centimeters squared. But this is quicker because if you use the Pythagorean theorem on the sides first, you realize this is a right angle triangle, And then you can use basic trigonometry to figure the angles out. All right, so that is what I wanted to clarify for this video. So we already did question 8. Let's move on to question 11. All right, so the diagram shows two circles, so with radius r, and the center of each circle lies on the circumference of another circle. So this radius, if I join a line like this is going to be the radius of a circle, right? Because it joins the center to its edge. All right, and if I join a line from this point to this point, that is also going to be the radius. And if I join a line from this point to this point, that is also going to be the radius, right? This is the center, this is its outer edge. So this is the radius of the circle, and they both have the same radius, r, right? And if I join from this point to the outer edge, that is also the radius. If I join from the center to the outer edge, that is the radius. This is the center to the outer edge, that is also the radius. So this makes an equilateral triangle, and an equilateral triangle has the angle 60 degrees inside, 60, 60, 60. So I'm going to write it as pi over 3. And what I am going to do is, below here, I am also going to have another triangle like this. And I'm going to name the outer region X. Alright, and you can obviously see that the area of the shaded region is the area of the two triangles plus the area, the 4 x's outside. Alright, so now we should be able to find the area of the two triangles. Two triangles is going to be 2 times the area of one triangle, right? Because they are symmetric. They are symmetric. It's the same triangle. So 2 times the area of one triangle is half base times height. So we just have base times height. What is the base? The base of the triangle is this. It's r. What is the height of the triangle? Well, let's see. If I take the sine, so x is this area, mind you. It's this area. That is x. The length, r, corresponds to this one. All right. So now I know that this is r. The x is just this area here. It's this. This is x. All right. So x is this one. So now, if I use some basic trigonometry, if I take sine of pi over 3, that is going to be my height of the triangle. And my hypotenuse is my radius, r. So height is just r sine pi by 3. And I'm going to use this information. So r times height is r sine pi by 3. So it's r squared. R times r is r squared. Sine pi by 3, sine 60 degrees is root 3 over 2. So it's root 3 over 2 r squared. So sine 60, you have to remember, is root 3 over 2. All right. So now we know the area of the two triangles. It's this expression. Now we need to find area of 1x, this x part, right? So how do we find the area of the x part? Well, look at this. If I find, let me highlight it for you, but I can find the area of this sector by using the area of the sector formula, right? Because this angle is pi by 3, and I know the radius, it's just r. So I can find the area of the yellow sector. So area of the yellow sector is half, the angle is pi by 3, and the radius is just r squared. So if you solve for this, you're going to get pi over 6 r squared. But remember, that is the entire yellow part. I just want to find x. So x is just going to be area of the yellow part, which is this, minus the area of the triangle. So if I subtract this outside away from the yellow part, I'm going to get x. So area of the triangle, if it's the area of two triangles is this expression, then area of one triangle is just going to be half, right? So this divided by 2. So this was the area, remember, this was the area of two triangles. So if I want to find the area of one triangle, I need to half it. So to find x, I will get root 3 over 2 divided by 2, 4r squared. So x is going to be this expression. And now, we can finally find the area of the shaded part. Remember, we already discussed that the area of the shaded part was one triangle plus the other triangle plus 1x, 2x, 3x, and 4x. So it was area of 2 triangles plus 4x. Area of 2 triangles is just this expression. So it's root 3 over 2r squared plus 4, and I know the value of x. It's this one. So it's pi over 6r squared minus root 3 over 4r squared. All right, and now we can finally simplify this expression. So I get root 3 over 2r squared plus 2 pi over 3r squared minus root 3r squared. And I can factor out the r squared. And if I factor out the r squared, I get this expression. Root 3 over 2 plus 2 pi over 3 minus root 3. And I can write this as 2 root 3 by 2. 2 and 2 cancel out, so I still have root 3. And I can simplify these two terms. So I get root 3 over 2 minus 2 root 3 over 2 gives me 2 pi over 3 minus root 3 over 2. So this is 1 root 3 over 2 minus 2 root 3 over 2 is minus 1 root 3 over 2. And I can actually factor out a 3 as well to match the expression given in the textbook. And I will get 2 pi minus 3 root 3. So you bring 3 inside, you get this. You bring this inside, these and this will cancel out, and you get root 3, which is what you started with, right? 3 root 3. All right. Let's see. Let me see. I think I made a mistake. So this one, 2 pi r squared over 3 minus root 3 r squared. All right. 2 pi r squared over 3 minus... Ooh. Okay, sorry. This is not correct. Okay, let's simplify here. And yeah, this is correct. This is correct. So this is your answer. R squared minus root 3 over 2 r squared. So you can put it inside, or this expression is correct. 2 pi r squared over 3 minus root 3 over 2 r squared. This centimeter squared is your answer. That is the area of the shaded part. All right. So we are done with question 11. I know it wasn't easy, but I hope the explanation made sense. All right, so I hope I can erase everything. I hope the diagrams were clear. Okay, so let me erase everything. Question 12. Question 12 is not easy at all, but I hope the explanation will make sense. So here is how we are going to approach question 12. Is if you think about it, this is given to be a square of side length 10 centimeters and a quarter circle of radius 10 centimeters, right? So this is 10. And this also lies on the circle. So I can draw this here. And this is also 10. And I can draw this like this. Because are all quarter circles, these are going to be 10 as well. I hope that was clear. And 10, 10, 10. This is an equilateral triangle. So this angle is going to be pi over 3. So think about this. This is a circle. If you start from here, because it's a quarter circle, this is the radius of that circle. So that radius is given to be 10. And it's the same quarter circle here, right? This is the quarter circle. This is another radius of that quarter circle. So that is 10 again. All right. So you have 10, 10, and pi over 3, and you have 10 below. All right. So now, what I am going to do is I am going to find the area of this sector. This yellow sector. This is what I can find, right? All right. So area of the yellow sector. So that is something I can find. So area of that yellow sector is going to be, so I'm going to write the angle. It's pi by 3, right? It's half. The angle is pi by 3. The radius, remember, is 10 squared. And if you simplify everything, you will be getting 50 pi over 3 centimeters squared. All right. So if 10 squared is 100, 100 divided by 2 is 50, 50 pi over 3 centimeters squared. That is the area of the yellow sector. All right. And now, let's notice another angle. If this is pi by 3 and this is a right angle, then this angle should be pi by 6. Why? Pi by 3 is 60. 60 plus what number gives you 90? Well, the rest has to be 30, right? And 30 in radians is pi by 6 radians. And we only work with radians in this topic. All right, so now we can find the area of the other sector. And the other sector is going to be this green sector. All right. So what is the area of the green sector? We can find it out. Area of the green sector, which has the angle pi over 6, is going to be half pi by 6. The radius is still 10 squared. And if you solve for this, you are going to get 25 pi over 3 centimeters squared. So 10 squared is 100. 100 divided by 2 is 50. And 50 divided by 6 is equivalent to 25 over 3 pi centimeters squared. All right, so we have the area of the two sectors. Now, let's find the area. We can find the area of the triangle, right? We can find the area of this triangle. So now, what is the triangle? Well, it's this triangle that I'm talking about. All right, so we can find the area of the triangle. So the area of the triangle is half. What is the base? The base is just 10. And what is the height? Well, height, you have to drop an angle here, right? And this is going to be your h. And how do you find h? Well, this angle is pi over 3. So if you take sine of pi over 3, that is equal to h over the hypotenuse. This is the right angle, so the hypotenuse is 10. This is the hypotenuse. So h is just 10 sine pi by 3. All right, so h base times height is just 10 sine pi by 3. So that is going to give you 50. This is half of 10 is 50. 5 times 10 is 50. And sine pi by 3 is root 3 by 2. Sine pi by 3 is root 3 by 2. And if you solve everything, you are going to get 25 root 3. All right. So now we have the area of the triangle as well. So if you think about it, what I can do is so let me erase what I have so far, and I'm going to redraw stuff again, right? I hope you remember. You can go back to the video and remember what each portion was. But I'm going to erase this, and I'm going to redraw the important parts. This was 10. This was 10. And we knew the area of this sector in yellow. The yellow sector was, I believe, this part, right? It was this part. This was the yellow sector. So if you think about it, if I do area of the yellow sector minus the area of the triangle, I get this part. Area of the yellow sector minus the area of the triangle gives me, I'm going to call this region X. All right, so how do I find X? So X is the area of the yellow sector, the big yellow sector, minus the area of the triangle. And what is the area of the yellow sector? Well, it was this. Minus the area of the triangle is just 25 root 3. All right, so now I know what X is. And now, if this is X, this part is also X, right? By symmetry, because it's a symmetrical situation on either side. So if you think about it, now is the key moment, is the eureka moment. I know the area of the green sector. If I do area of the green sector, the previously green sector, minus X. So if I do area of the green sector minus X, I am going to get area of this purple part. So this part in purple, muddy purple, let's just say. This part in muddy purple is going to be area of the green minus the area of X. All right, so area of the muddy purple, let's just say, the muddy purple region is equal to area of the green sector minus x. All right, so what is the area of the green sector? It's 25 pi over 3. What is x? X is this expression. It is 50 pi over 3 minus 25 root 3. All right, and if you simplify this expression, you are going to get 25 root 3 minus 25 pi over 3. So 25 pi over 3 minus 50 pi over 3 is negative 25 pi over 3, which is this part. And then negative negative gives you positive of this part. So that is the muddy purple section. And finally, if I erase everything so that I can redraw my parts again, this was the muddy purple section, right? Okay, sorry, it's seeping in, which it shouldn't do. So let me go closer. But this was one muddy purple region. Okay, sorry. Let me just color it in with the other pencil instead of the highlighter. Okay, this part. So this was the muddy purple section, the one I'm drawing in pencil. So this was the muddy purple section, if you remember. So if you pause the video and if you go back, you're going to notice that this was the muddy purple section. All right. And remember, you had a straight line here like this. So this was your x section. All right. So now you see x, you can visualize it. You see your muddy purple section again. So I'm going to really erase x because it's not really relevant anymore. But this was your muddy purple section. And if you look carefully by symmetry, you see that you have exactly 4 sections like this. This is 1. So I'm going to call it section 1. Now let me point out the other section. Exactly the same area you have, the other section is here, right? That is going to be number 2. Let me show you one more. This section is the same section, is this with the section of the same area. So this is section 3. And you have one more right over here. This section is section 4. So if you do the area of your square minus 4 times the area of the muddy purple section, so area of the square, which you can find, minus 4 times the area of the muddy purple section that we found, that is the area of the shaded part. That is this central shaded. That is this central shaded area. What we were looking for, that is this part. All right, so now, what is the area of the square? Well, this is 10, this was 10. So that is just 100, right? 10 times 10 is 100. Minus 4 times the muddy purple section, which is this part, right? So 25 root 3 minus, so 25 root 3 minus 25 pi over 3. And if you simplify, you get 100 minus 100 root 3 plus 100 pi over 3. And if you factor out the 100, you get 1 minus root 3 plus pi over 3 centimeters squared. And that is your final answer. 1 minus root 3 plus pi over 3 centimeters squared. And that is your final answer. All right. So it's a neat answer, but it takes very long. And it's not simple. It's not simple at all. All right. So I hope I can erase it and move on to the next question. Okay. Question 13. So it says that this diagram shows a circle with radius 1, center O. So this black part is 1, this part is 1, but maybe that's not helpful. Triangle AOB is a right angle triangle. So this is the right angle triangle. And its hypotenuse AB. So this is the hypotenuse. So that means opposite to it we have the right angle, is a tangent to the circle at P. So that means that I can technically drop a radius from O to somewhere here, and that is going to be equal to the radius of the circle, which is 1. All right, that is very important to know. So now, part A says find an expression for the length of AB in terms of tan of x. Well, let's just find tan of x first. Tan of x, tangent of x of this angle x, is opposite, which is 1, over adjacent, which is AP. So if you think about it, AB, because it says find AB in terms of x, AB is this AP plus PB. And what is PB? PB is this value. All right. So now I know AP. AP, from this expression, AP is going to be 1 over tan x, right? Just switch. You take AP here, you take tan x here, you're going to get this expression. So AB is 1 over tan x plus PB. Now let's figure out what PB is. And to do so, we'll use some geometry. So this is what we had, right? And I dropped a radii like this because this is a tangent. This must be a 90-degree angle. This is x. This is 90. This is clearly 90 minus x. And remember, this was also 90 degrees. So 90 minus x plus this angle, which I'm going to call beta, should equal to 90 as well, because this was previously our 90 degrees, right? Because this triangle is a right angle. The orange triangle is a right angle triangle. All right, so subtract 90 on both sides. You get minus x plus beta is equal to 0, and beta is equal to x. So this angle is going to be x. And now let's take the tan of our new angle x, this one. It's going to be opposite, which is PB. And what is our adjacent? Well, adjacent was 1, because we dropped the radius perpendicular to the tangent. So tan x is just PB, or PB is just tan x. And we can substitute that value here. So AB is just tan x plus 1 over tan x centimeters. All right, so we are done with A. It says find the value of x for which the two shaded areas are equal. So I hope I can erase everything. Okay, so what are the two shaded areas are equal? Okay, so we can solve this. What is the area of the orange triangle? Of the triangle is half times base times height. Half, what is the base? Base is AB. This is the base. All right. AB is something that we found. The height was this perpendicular, right? This is going to be the height of the triangle. And we know that this is just 1. All right. Times 1. And remember, AB was 1 over tan x plus tan x. That is the area of the triangle. What is the area of the blue part, this part of the circle? Well, that is, if this is 90, then this is 360 minus 90, right? And we need to use radians. All right. So if that was 90, then this angle is just going to be 360 is 2 pi minus 90 is pi over 2. So 2 pi over pi minus, so area of the sector is going to be half the angle, 2 pi minus pi over 2. That gives you 3 pi over 2. And the radius squared, what is the radius? It's just 1 squared. 1 squared. So we need to solve for this. So this gives you 3 pi over 4. So we need to solve for half 1 over tan x plus tan x is equal to 3 pi over 4. So if I multiply by 2 on both sides, I get 1 over tan x plus tan x is 3 pi over 2, right? Is 3 pi over 2. So now let me multiply by tan x on both sides. And if I do so, I'm going to get 1 plus tan squared x is equal to 3 pi over 2 tan x. And this, if you remember your Pythagorean identities, sine square x plus cos square theta is equal to 1. 1 plus tan squared x is going to be secant squared x, and 1 plus cotangent squared x is cosecant squared x. So these are what we call your Pythagorean identities. We are going to look into them more in the future videos. But we are going to use the Pythagorean identities now. And this matches this expression. So my left-hand side is just going to be secant squared x is equal to 3 pi over 2. And tan x, by definition, is just sine x over cos x. And secant squared x, by definition, is just 1 over cos squared x. So now if I multiply by cosine x on both sides, these will cancel out. Cosine x and 1 cosine x cancel out here. So I get 3 pi over 2 sine x. And if I divide by sine x on both sides, I get this expression. So now let me multiply this. So if I multiply the numerator 2, I can multiply my denominator by 2, right? So now I can rearrange this expression. I can bring 2 here. I can write it as 4 is equal to, I can multiply this here. 2 sine x cosine x. And I can write this as 4 over 3 pi is equal to 2 sine x cosine x. By definition, 2 sine x cosine x, we have an identity which makes this equal to sine 2x. So we are going to substitute sine 2x here. And 2x is going to be sine inverse of 4 over 3 times pi. So if you use your calculator, you are going to get the value inverse of 4 divided by 3 times pi. If you put this in your calculator, you are going to get the value of 2x to be 0.4383137046. And finally, your x is going to be half. So 0.219 ... radians. So to 3 significant figures, it's just 0.219 radians. And we are done. We are done with part B. So the final question is question 14. The diagram shows a sector AOB of a circle. So this is the type C. We are given show that something and show that something, right? So let's try to do B, because immediately you can use the information given in A to solve B. Even if you can't solve A, you should be able to solve B in such questions. So area of inner circle. We are given an inner circle, center O with radius R. Sorry, inner circle of radius R, right? So area of inner circle over area of sector. Inner circle is just pi r squared. What is the area of the sector? Well, it's going to be half. The angle is pi by 3. And the radius of the big circle, the circle sector with radius r, right? So r squared, capital R squared. And now you can simplify. So pi r squared divided by, you have pi over 6, capital R squared. Now we are already given r is 3, capital R is 3 small r. So just substitute that. So this 6 will actually go to the numerator, and you have 3r squared. This capital R becomes 3r. This 6 went to the numerator. Now pi and pi cancel out, so you have 6r squared divided by 9r squared in the denominator. So r squared and r squared cancel out, so you get 2 over 3. So we were able to show B using A, right? Even if you can't solve A, you can solve B in this case. So now let's solve A. So show that r is equal to 3r. So this is a small circle. I'm going to take this to be the center. This is going to be my radius r to the point of tangency here. This is going to be my radius r to the point of tangency. This is going to be my radius r here to the point of tangency. All right. And now let's try to figure the angle out. This angle, I can figure it out because this circle has an angle of 2 pi. And because it's 3 equal sections, right? I've divided the circle into 3 equal parts by drawing it like this. I just need to divide 2 pi over 3. So 2 pi over 3 is my angle here. So I have divided my circle into 3 equal parts by drawing my radii in this way, because I've taken one here, taken one here, and taken one here. So this divides the circle into 3 equal parts because I've drawn my radii to the point of tangency. All right. So now I know this. I have sort of like this. Well, if you think about it, this is a right-angled triangle, right? This is a right-angled triangle. So now here's what I can do. I know, let me call this part to be my x, and I know that this part is just the radius, right? This part is just my capital R. And if you think about it, the whole thing is just the radius of my sector. So capital R is x, which is this part, is x, and then I have 1r here. I have r plus r. All right, so r plus r is just 2r. All right, sorry about that. I am back from lunch. Okay, so I know that capital R is x plus 2r. That is one takeaway. Now I need to solve for x. I know something else. I can use basic trick, right? I know this is 90. This is half of pi by 3. This is pi by 6. And you are going to see that if you do pi by 6 is 30 degrees. 30 degrees is pi by 6. So 90, 30, this has to be 60 degrees. So which is pi by 3. All right. So now, let's see. If I do sine 30 degrees, sine of pi by 6, if I take sine of this angle, opposite is r, my hypotenuse is x plus r. Right? And so, I can write x in terms of r. Sine pi over 6 is just half, right? Sine 30 degrees is half. So I get this expression. X plus r is going to be 2r, and x is just r. Right? If you solve this, cross multiply, and you get this equation, and then you get x is equal to r, 1r. And if you substitute it x here, you get r is equal to 3 small r. So that is it. That is how you do question 14. And I hope the answer, the explanation was clear. I know the questions are a bit hard for this topic. It's not easy. It's not intuitive. I used a lot of rules that you may not have heard before, but next chapter is trigonometry. So I'm going to make sure I hopefully can give you the sine rule and the cosine rules there so that you can sort of catch up and then revisit these videos later. All right. So I think that is the end of this topic and this chapter. I might make one more video about one more question that I wanted to show you, and that is the example question, because I don't think the solution is very clear in the example. So I might do that one again, but I think this is it for this topic. This is probably the topic with the hardest questions I've seen so far. Geometry is not obvious at all, but hopefully you were able to follow the explanations and get the answers. So yeah. I'll see you in the next chapter, the next video. Probably there will be one more video for one more the example question. But yeah, that is it. Thank you.